Hi, welcome to the graphs of the other four trigonometric functions, and that's my lazy way of saying the graphs of tangent, cotangent, secant, and cosecant. My name is Tuesday J. Johnson. I'm a lecturer at the University of Texas El Paso and an assistant professor at Doña Ana Community College. This is Math 1508 Pre-Calculus at UTEP, but it's the same as pre-calculus across the country. Chapter 4 Trigonometry comes to us from Larson's 10th edition pre-calculus text. Section 4.6, it's titled Graphs of the Other Trigonometric Functions, so I just went with that one. So let's start with the graph of y equals tangent of x. And in order to find the graph of y equals tangent of x, keep in mind that tangent is sine over cosine. So we know that the zeros of a rational expression are when the numerator is 0. So the tangent of x will be 0 when sine of x is 0. We also know that when the denominator of a rational function is 0 and the numerator is not, we'll have vertical asymptotes. We know that tangent of x will be undefined when cosine of x is 0. These will give us the asymptotes. Also, when sine of x equals cosine of x, tangent of x will be 1. So this will be at a pi over 4 reference angle. Keeping in mind the signs of the tangent in the various quadrants, we can plot the graph. Now, when x is 0, sine of x is 0, so tangent of x is 0. When x is pi over 2, cosine of x is 0, so we'll have an asymptote. At x equals pi over 4, tangent is a positive 1. At negative pi over 4, tangent is a negative 1. At negative pi over 2, cosine is 0, therefore tangent has an asymptote. And this is one complete period, and it repeats. So from pi over 2 to 3 pi over 2, it looks the same. It's a nice little increasing kind of curvy graph. This is not high quality drawing by any means. So here's a better view of it, and I do not remember who I stole that from. So if you see this graph and you want to claim it, you tag yourself right here in this YouTube comments, and you'll have my apologies because I love this. From negative pi over 2 to pi over 2, we have the first period, increasing graph, nice little curves, just kind of lazy curves going up, tangent. Now, the vertical asymptotes of tangent of x are when cosine of x is 0, so x equals negative pi over 2 and x equals pi over 2. For various shifts in the graph of the tangent of x, we could find any two consecutive vertical asymptotes by solving bx minus c equals negative pi over 2 and bx minus c equals positive pi over 2. And what the heck is bx minus c? Well, that's if y equals a tangent of bx minus c plus d. Alright, so the bx minus c is what's ever going on inside of the tangent, so the argument of the tangent function. So left asymptote, bx minus c equals negative pi over 2, and a right asymptote at bx minus c equals pi over 2. Because of this, right, because tangent is positive in quadrant 1 and again in quadrant 3, and it just so happens that it takes place in one pi period of time, one period is equal to pi. Now let's talk about cotangent. We know that the cotangent of x is cosine of x over sine of x. So the cotangent of x will be 0 when cosine of x is 0. We know that cotangent of x will be undefined and have asymptotes when the sine of x is 0. And we know that cotangent is equal to 1 when cosine of x and sine of x are equal, which is at pi over 4. Keeping in mind the signs, positive and negative signs of the quadrants, we can graph cotangent of x. So I know, starting here at 0, sine is 0, so I have an asymptote. At pi over 4, both sine and cosine are square root of 2 over 2, so my cotangent of pi over 4 will be 1. Cosine of pi over 2 is 0, so cotangent of pi over 2 is 0. At 3 pi over 4, cotangent is negative 1, and then at pi, we'll have another asymptote. Notice, this looks a lot like the graph of tangent, only these are little decreasing curves. And of course, a better view of it, analyzemath.com, it's where I stole this one from. It looks like Maybe I got the previous one from there also. I don't know. But it's the same. You know, it's nice little, just looks prettier than mine. But it's the same idea. If you want to find two successive asymptotes on here, you would set bx minus c equal to 0 and bx minus c equals to pi, and then you can find the basic idea of what's going on in between them. If I want to graph secant and cosecant, I remember their definitions. I think about them as the reciprocals. Remember that cosecant of x is the reciprocal of sine of x. So if you can graph sine of x in gray, then ignore that gray. That's just our little lightly drawn in lines. It gives us the pattern. So I know when sine is 0, cosecant will have asymptotes because that's going to be now my denominator. When sine of x is 1, well, the reciprocal of 1 is 1. So reciprocal of negative 1 is negative 1. And then I just flip my little parabolic shapes upside down. And there's the graph, just in black, is the graph of the cosecant function. Similarly, we know that y equals secant of x is the reciprocal of cosine of x. So if you can graph the cosine of x, a little ugly there, but you know, basic idea. The zeros of the cosine will be asymptotes of the secant. Reciprocal of 1, reciprocal of negative 1, and so on. And we have our parabolic shapes. I use cosine of x at first just to kind of give me an idea of where my little parabolas are going in between my asymptotes. But eventually I want you to be able to draw it without using the sine of x and the cosine of x as a guideline. You should be able to put that in without them. And here we have, notice they're in opposite orders now. The secant of x, secant, is the reciprocal of cosine. Cosine's high, it starts high, so flip over that parabola. Flip over our little curve. Flip over the little curve, and over here's cosecant of x. This is the one we talked about first on the previous page. And you can see asymptotes for cosecant are at 0, pi, 2 pi, 3 pi. That's when sine is 0. That's the same as the asymptotes of the cotangent. So cosecant and cotangent both have asymptotes at 0, pi, 2 pi, and so on, because they both have sine in the denominator. Whereas secant and tangent, remember they buddy up, they will in calculus also, secant and tangent have the same asymptotes at negative pi over 2, positive pi over 2, 3 pi over 2, all the odd pi's over 2, just like tangent does, because cosine is in the denominator, and that's where cosine is 0. Alright, so we're going to sketch the graph and include two full periods for the tangent and cotangent, since they both have a natural period of pi. We put in two views of them, so we get a full 0 to 2 pi. Looks like my image kind of overlapped my typing here. Waste of time typing. Pi over b is the period of tangent, and in this case, that makes it pi over 4. So I know my period is pi over 4. What I'm going to do is to find my leftmost asymptote. 4x equals negative pi over 2, so x equals negative pi over 8, first asymptote. 4x equals negative pi over 4 gives me x equals negative pi over 16, my negative 1 value, right? Always. Asymptote, negative 1, 0, 1, asymptote. Negative 1, 0, 1, asymptote. So asymptote. This is an output of negative 1. This will be an output of 0. This will be an output of positive 1. This will be an output of asymptote, always. Increasing graph until, of course, we do a reflection. Wow, language is going away. I've recorded too many videos today. A vertical reflection, of course, things are going to change, but ignoring vertical reflection, it's always going to be asymptote, negative 1, 0, 1, asymptote. Negative 1, 0, 1, asymptote. We just have to find the x values that take us there. Looking at 1/4 secant of x. If I was thinking of this as cosine, the amplitude would be a fourth. But remember, amplitude is half the distance between the maximum and the minimum. Secant doesn't have a maximum or a minimum. So the amplitude in cosine helps us, but we don't call it an amplitude when it comes to secant. It does help us label our y-axis though. The graph in red is the only one we want to consider. The graph in gray is just a model. the y equals cosine. Try to get to a point that you don't need it, but for now, it's a little easier to see. 3 cosine of 4x. The 3 gives us the y scale, right? Because that would be the amplitude if this were sine. Cosecant doesn't have an amplitude, but we do need to know where we start or flip it over. The 4 is a horizontal shrink with the period, 2 pi over b, which is 2 pi over 4 or pi over 2. Cosecant has a denominator of sine, so my asymptotes are going to be at 0. Then 4x equals pi, so x equals pi over 2. 4x equals 2 pi, so x equals pi over 2. So I have my asymptotes. And in between them, I start up, and then I go down because I don't have a reflection. Finally, 2 times the cotangent of x plus pi over 2. The 2 gives the y scale. All right, so now instead of being values of 1s and negative 1s, this tells me I'll have 2 and negative 2. This, x plus pi over 2, the pi over 2 is a horizontal or phase shift to the left. So instead of cotangent starting at 0, I'm going to start back pi over 2. Notice this is in quadrant 4, and in quadrant 4, cotangent is negative, so negative 2. If I go back pi over 2 units, at 0, I'll have a height of 0. At pi over 4, a height of 2, and then an asymptote. And then the same thing. Notice this is exactly what a cofunction is. Cotangent of x plus pi over 2 is equal to tangent. Throw in the 2 as a scaling, but cotangent, if I shift it left to pi over 2, that's just the graph of tangent. It's exactly what it means to be a cofunction. So the graphs of the other 4 trig functions, all based on the graphs of sine and cosine. Here's a little tip to my students that are listening ahead. You will have a quiz over this. If you do not have the graphs of sine and cosine memorized, life will be hard later in this class and also in calculus. You know your times tables, people. This is the same thing. Just memorize a unit circle, some reference angles, and of course, asymptotes. Know these. Graphs of sine and cosine. Thanks for listening.